Okay, over here to the left, I've got some expressions that kind of show you where we're headed. We're trying to find the exact value of the sine of twice the angle that has a tangent of 12/5. The first thing that you want to realize is that this is an angle. The angle that has a tangent of 12/5, inverse tangent of 12/5. So if I think of that as the angle theta, which I did over here, I said theta equals the arc tangent of 12/5. This is in radian mode, by the way. And then I said, well, what's the sine of twice theta? It's 120 over 169. And, oh, where did this come from? Well, that's the double angle identity for the sine function. The sine of twice an angle is 2 sine theta cosine theta. And that turns out to be 120 169ths also. And I put the equation of the circle in here to convince you that the hypotenuse of this right triangle with a leg of 5 and another leg of 12 is 13. And you might recognize that as a 5, 12, 13 Pythagorean triple. But if you didn't, you could use the Pythagorean theorem to do it this way. Okay, so there's what we're working at. There's the double angle formula for sine of twice an angle. And now we just have to look at this diagram to fill in the sine of theta and the cosine of theta. If this is theta, the angle that has a tangent of 12/5, the sine of theta is opposite over hypotenuse, 12/13. The cosine of theta is adjacent over hypotenuse, 5 over 13. And if I multiply these numerators together, 60 times 2 is 120. 13 times 13, 169. So these steps show you how to do it manually. What happened over here is how you could convince yourself that indeed we have the right answer. There you go. Hope that helped. If you have a question, post a comment.